Multi-engined aircraft AC supply distribution systems will either be of the split busbar type, where each generator operates independently, or of the parallel busbar type, where each generator carries a share of all the loads. In this lesson, we will look at the split busbar type of system. In a very basic form, shown here is the general layout of an electrical distribution system for a twin-engine jet aircraft. The system will be very much the same whether the system is of the split or the parallel busbar type. One generator is driven by and mounted on each engine, and one generator is driven by the auxiliary power unit. The feeder cables from each generator are routed through the aircraft wings and fuselage to meet at a central distribution compartment, usually beneath the flight deck or cabin floor. This distribution compartment will house many of the components we have already seen, including generator control breakers, bus tie breakers, generator control units, voltage regulators, main bus bars, the battery and the battery charger. Busbar extensions may be found on the flight deck behind the circuit breaker panels. The split busbar system of a two-engine aircraft uses two 115/200 volt, 400 Hz, three-phase AC generators driven by the engines as the primary power source. They are not designed to run in parallel and therefore do not require complex paralleling and load-sharing circuits. In particular, the phase sequence of the generators does not need to be aligned. Each generator supplies, through its generator control breaker, its own AC busbar. And these busbars, in turn, supply two non-essential AC busbars. The two generator busbars can be connected together by a normally open bus tie breaker. The essential AC busbar is supplied from number 1 generator busbar through a changeover relay. DC power supplies are provided by transformer rectifier units, or TRUs. The non-essential DC busbar is supplied with 28 volts DC by a TRU connected to number 2 AC busbar. The essential DC busbar is supplied with 28 volts DC by a TRU connected to number 1 AC busbar. These two busbars are connected together through the normally closed DC isolation relay. The 24-volt aircraft battery is directly connected to the battery busbar, which in turn is directly connected to the vital or hot DC busbar. The battery is connected to the essential DC busbar by the normally closed battery relay. In the event of a double generator failure, the essential AC busbar can be supplied by a static inverter connected to the essential DC busbar. The APU generator can supply either one or both main AC busbars. On the ground, it can be used to power the entire aircraft. However, in flight, it may be limited to supplying only one busbar. A suitable external AC supply can be connected to number 2 AC busbar. From here, it can be used to power all of the aircraft systems. This is how the system will look during normal operations, with both engine-driven generators online. The two engine-driven generators will supply their individual main and non-essential busbars through the close contacts of their generator control breakers. The bus tie breaker will be open, keeping the generators apart. Remember, in this type of system, the generator outputs are never connected together. The essential AC busbar will be supplied from number 1 AC busbar. The DC essential and non-essential busbars will be joined together by the closed contacts of the DC isolation relay. The battery relay contacts will be closed, connecting the battery to the DC essential bus bar. The battery will be supplying both the battery bus bar and the vital bus bar. If either generator should fail, its generator control breaker will open, disconnecting the generator from its bus bar. The bus tie breaker will close automatically, thereby maintaining power to all bus bars from only one generator. Loads on the non-essential bus bars can be shed if required. If necessary, the APU can be started so that its generator can be brought online to replace the failed engine-driven generator. In this case, the bus tie breaker will open once more to isolate the APU generator from the serviceable engine-driven generator. If both engine-driven generators should fail, once again their generator control breakers will open, disconnecting them from their bus bars. The main AC bus bars and their associated non-essential bus bars will no longer be powered. The battery will power the DC essential bus bar through the closed contacts of the battery relay. And the DC isolation relay will open, cutting off power to the DC non-essential bus bar. Finally, the changeover relay contacts will move over, allowing the static inverter, supplied by the battery, to power the AC essential bus bar. The only bus bars that will now be powered are the AC essential bus bar, the DC essential bus bar, the battery bus bar, and the vital bus bar. Depending on the fault, it may be possible to start the APU and use its generator to recover the lost bus bars. If the electrical system is operating on battery power alone, then the battery must be able to supply the essential services for 30 minutes on aircraft certified to EASA CS23 and for 60 minutes on aircraft certified to EASA CS25. Displayed on the screen now is the Split Busbar system typically used on two-engine Airbus aircraft. The diagram is laid out in the style you can expect to find in the aircraft's aircrew manual. This system has all of the components we saw on the last system, the only major differences being that this system has two batteries and an emergency generator. You will also notice that the various electrical relays that are used to control the system are referred to by Airbus as contactors. So, for instance, the component that previously was referred to as Generator 1 control breaker is in this system known as Generator 1 contactor, same component, different name. The engine-driven generators are connected to their individual bus bars by their generator contactors. In the event of a single generator failure, the bus tie contactors will close to supply both bus bars from one generator. On the ground, external power or the APU generator can supply all services. In flight, the APU generator can be used to replace a failed generator. The AC essential bus bar can be supplied from a number of sources. It is normally supplied from AC bus bar 1. But it can be supplied from AC bus bar 2. If neither of these bus bars is available, then the emergency generator, driven by a hydraulic motor, supplied from the aircraft's hydraulic system, can be used. Finally, if hydraulic power is not available, the static inverter supplied by the batteries through the DC essential bus bar can be used to power the essential AC bus bar. DC bus bars 1 and 2 and the essential DC bus bar are normally supplied by transformer rectifier units connected to their respective AC bus bars. The DC battery bus bar connects numbers 1 and 2 DC bus bars together. It also allows power from these bus bars to charge the batteries. If the essential DC bus bar loses its normal power supply, it can be supplied from either one or both of the batteries. This system is almost completely automatic in its operation. In the event of a failure or failures, all configuration changes are carried out automatically. The pilot, however, does have a control panel with a limited number of switch lights on it. When the system is operating normally, all lights on the panel are out. The generator 1 and 2 switch lights allow the pilot to switch off the engine-driven generators by opening their respective generator contactors. The fault light in the switch will illuminate if the generator contactor has been opened by the automatic control system because of a generator fault. The APU and external power available lights illuminate green when the associated power supply is available with its voltage and frequency within limits. The APU generator will come on as required unless the pilot pushes the switch light to lock it off. Pushing the external power switch light will bring the external supply online. The integrated drive generator or IDG disconnect switch lights each have a fault light which will illuminate if the associated IDG oil pressure is low or oil temperature is high. Pushing the guarded switch light will disconnect the associated IDG from its engine. The bus tie switch allows the pilot to lock the two bus tie contactors open. As we have said, the essential AC bus bar is normally supplied from AC bus bar 1. The AC essential feed switch allows the pilot to select AC bus bar 2 as the source of supply for the essential AC bus bar. The two battery switches allow the pilot to disconnect the battery charging circuits by locking open the battery charge contactors. The fault lights in the battery switch lights illuminate if the battery charging current is excessive. The galley switch light allows the pilot to cut off the power supplies to the galleys or shed the galley loads. This may be required when operating with only one generator online. Finally, the voltages of the two batteries are continuously displayed on the panel. Operation of the system can be monitored on the aircraft's electronic display screens. The oil temperatures of the engine-driven IDGs are displayed here. The output voltages and frequencies of all operating generators is displayed, along with the load being taken by the generator as a percentage of the generator's capacity. The output voltages and current being supplied by numbers 1 and 2 transformer rectifier units are displayed here. The battery voltages are also displayed along with any charge or discharge current. In the event of a malfunction, the display will change to show the new configuration. Here, for instance, generator 1 has failed and it has been replaced by the APU generator. That is the end of the lesson. The most important point to remember from this lesson is that in split busbar type systems, the various sources of AC power are never connected to the same busbar. Here are the other points you should take from the lesson. Because the generators are never operated in parallel, phase sequence does not need to be aligned between the generators. In most systems, the essential AC busbar is normally supplied from number 1 AC busbar. In the event of the loss of all generators, a static inverter powered from the battery will supply the essential AC loads. In the event of a single generator failure, busbars 1 and 2 are connected together by the bus tie breaker. On the ground, an external power supply can be used to power all of the busbars. When you are happy with these points, continue to review the Airbus system circuit diagram. Here is the Airbus system in its normal in-flight configuration. Spend a few moments making sure you are familiar with it before you finish the lesson.